Yes, good morning. Today we are going to enter our day 3 lab session. In that we are going to see buzzer and a few more things. Before that, as usual, we will recollect the things what we have discussed in the day 2 class. In day 2 class, we have seen how to interface switch and LED. So in switch and LED, we undergone few experiment. The one is if the switch is in on condition, make the LED to on. Else, turn off the LED. And the second one, toggle the LED condition based on the switch press. Okay. So this is our first experiment. So here we use a slider switch, SPDT switch. If you turn on the switch, LED will get turned on. If the switch is in off condition, LED will be remains off. I hope everyone understood the experiment. So this is the first experiment what we have did last class. Then our second experiment was toggle the LED. So here we have a push button and LED. If you press the push button, the LED state will get toggle. Toggle means 1 to 0 or 0 to 1. If my LED in on condition, it will go back to off condition. If it is in off, it will become on. Okay. I hope these things were familiar to you. Now we will enter into the day 3 class. In today's class, as sir told you already, we are going to interface switch and buzzer. So LED will give visual effect, buzzer will give audio effect. Okay. So the buzzer output is input for our ears, LED is for input for our eyes. So what we are going to do now? In the first exercise, as usual in the LED, by reading the switch status, we are going to control our buzzer. If my switch is in on condition, make the buzzer to on, else turn off the buzzer. So the program part is very much similar to our LED and the switch control. Only the hardware connection we are going to modify it. So it is very simple. Then the second experiment is the tone. So this tone, you may aware of this tone because most of the two-wheelers and four-wheeler vehicles, you are having different tones for reverse parking, even for horn also you are creating some tones. So not only we are going to turn on and turn off the buzzer, we are also introducing the tone effect with the help of our buzzer. Okay. First we will see how to, if the switch is in on condition, make the buzzer to on, else turn off the buzzer. Please observe the video, then we will start do the exercise. Is it audible to everyone? Is it audible? If my switch is in off condition, my buzzer remains off. If I turn on the switch, buzzer gets on. It's a very simple program. Here I am going to interface same switch as an input device. Only the change is the buzzer. Please observe the hardware connection. So I am connected pin number 12 as an output pin, and it is connected to the one end of the buzzer. Another end of the buzzer is permanently connected to the negative terminal. Again, switch I am going to connect it into the input terminal pin number 4. So as for this schematic diagram, now we need to write the algorithm. Okay. Now we will come to the program part. First we will see the algorithm. So there are one input. Wait a minute. There are one input and one output. So as usual in pin mode, I need to configure the input and output pin. So first in void setup, I am going to configure pin number 4 as an input. Then pin number 12 as output. As usual, by default, in void setup, I will make all the output devices into off state. So make pin 12 to logic low. See why we are doing this means whenever there is a power shutdown See, I'm using one induction motor, some other device, it's a rotating object. If power cuts off, then again it comes back. My motor should not run without I give the input signal. See, at the time we do cleaning action, something else. At the time, if power comes immediately, if motor start rotates, we will get injured. Okay, so to avoid that, we are making the output device as a off during the initial condition. Then loop, get into the in setup, what is the actual program. So the configure pin number 4 as an input, you know very well, pin mode 4 comma input. Then can anyone tell what is the next one? How to configure pin number 12 as output? Please type it in chat box. How to make the pin number 12 as output? Pin mode 12 comma output. Very good. Then how to make the pin number 12 to low? It's very simple. Digital write 12 comma low. So that's all in the void setup. In loop function, as usual, we are going to read the status of the switch. By reading the status of the switch, we are going to check the condition of the switch. The switch is in on condition, make the buzzer to on. Else, make the buzzer to off. It's very simple. Now we will see the program part. Read the status of the switch. So since we have connected switch in pin number 4, we are going to write digital read of pin number 4. So I'm going to store it in the variable called SW, and I'm going to check the condition of the switch. If my switch is in on condition, turn on the buzzer. Else, turn off the buzzer. I hope it is clear for everyone. Now we will enter into the simulation part. I hope it is visible to everyone.
Visible,
yes,
getting
now I am getting entered into the Tinkercad software. Go to circuits. Click create new circuit. Click create new circuit. Rename the experiment switch and buzzer. So switch and buzzer. Yes. What are the hardware components I need to take? Please help me. First Arduino, and then breadboard, and then slide switch, then one resistor, then what else? Today we are going to take one output device. See, if you are not viewing all the components, change this as a basic into all. Then only you can view all the components available in this particular software. See, now go to output. Output. That output, instead of LED, today we are going to select piezoelectric buzzer. Okay. And what else we want? That's all. Switch we have, resistor we have, and buzzer. See, please observe the buzzer terminal. Buzzer has two terminal, as I told already. It is a polarized device. So polarized means the polarity we need to mention. See, positive. Positive means here we need to apply plus 5 volt. In this negative, we need to connect it to the negative terminal of our supply source. Okay. Now we are start do the connection. So again, I am going to use the pull down configuration. The resistor value, typically we will keep 10 kilo ohm. So I labeled the resistor value as 10 kilo ohm. So I'm going to drag the resistor and going to keep it in the particular position. Okay. Now, the one end of the resistor must be connected to the negative terminal. Before that, we will power our breadboard first. Yes, VCC and ground connected to the breadboard. Now I am going to start wiring my switch circuit. So pull down resistor. Therefore, one end of the resistor is connected to the negative terminal. Another end of the resistor is connected to the one end of my switch. And also from this common point, we are going to read the status of the switch. So the input terminal, what we are going to configure is the pin number 4. So therefore, I'm going to connect this particular input into the pin number 4 of our Arduino. Yes. Is it clear for you? And then, so this is the output terminal of my switch. This common terminal, I'm going to keep it as an input. So I'm going to connect it into the 5 volt. So that means whenever my switch is in off condition, then my circuit will get closed through this path, ground, resistor, then this wire, it goes back to the terminal number 4. If I made the switch to turn on, from the VCC, straight away it goes to the pin number 4. Then, what is a new thing today we have seen? Buzzer. So how to connect the buzzer? Simply take the buzzer, connect it like this, bring the cursor nearby this, which shows positive. So VCC or the output from the Arduino, we need to connect it to the this end of the buzzer. Okay. What about the other terminal? Can anyone tell where I need to connect this one? Can you type it in chat box? This negative terminal where we can connect. If I make the logic high, the 12th pin will get high. From where I will get the negative?
Yeah, mentioned it as
yes,
ground.
Very good. Yes, thank you, sir. Black. Is it okay? So now we have connected switch and buzzer. So please remember, I have connected buzzer in pin number 12 and switch in pin number 4. Okay, now we will come to the program part. So program part, go to text. Now we are going to delete the previous default program. Now we are going to start type our program. See left hand side, see the schematic circuit diagram. So the switch is connected in pin number 4. Buzzer is connected in pin number 12. Accordingly, we need to configure the pin numbers. Okay, so first I'm going to make pin mode. So the input pin is 4. So 4, input. 4, input. Why we have written this command? To make pin 4 as input. That's all. Then the next one, pin number 12. Pin mode 12, pin mode 12, output. Pin mode 12, output. What for this? To make pin 12 as output. That's all. Pin 12 as output. Then by default, I need to make this output pin as an logic low, digital write of 12, low. That's all. That's all. Now we come to void loop. What we have to do in this void loop, we need to read the status of the switch. So assign the variable name SW and read the status. So digital read of pin number 4. Why pin number 4? Since we have connected switch in pin number 4, we need to read the status from the same pin. Okay. So read switch status. Read switch. Then accordingly, I need to do my logical change. So if my switch is in on condition, the logic level what we that means logic high. If my switch is in on condition, my SW will be in logic high. If so, what I have to do? I have to turn on the buzzer. So buzzer is connected in pin number 12. So digital write of 12, high. That's all. If not, what I have to do? Can anyone tell? In else part, what I have to write? In else part, very good. We need to type digital write-off 12 comma low. 12 comma low. That's all. Please go through the program once. Port pin connected as input pin, pin 12 output, then digital write 12 comma low. Then we are going to read the status of the digital pin, and we are going to check the logic if switch is in on condition. If switch is in on condition, if switch is in on state, it is in on state, turn on the buzzer. Turn on the buzzer. Else turn off the buzzer. That's all. Turn off the buzzer. Okay. Now we will check. What I have to do after typing the program, what I have to do, I need to simulate. I need to click start simulate icon. Once you start simulate, the program will get simulate. If you want to disappear this code window, press this code menu once. Now hardware only get appear in your window. Now I need to check the output. Now my switch is in off condition. My buzzer is also off, so it is okay. Now turn on the switch. Yes, very good. My buzzer gets turned on. How to turn off the buzzer? If I turn off the switch, buzzer will get turned off. Is it okay for everyone? Is it clear? So if my switch is in off condition, my buzzer is off. If I turn on the switch, my buzzer will get turned on. Okay. So that's all. First exercise over. If you have any doubt, please type it in the chat box. Now we will get it into the second exercise. So now you may observe the sound. It is with a single frequency. But if you have to give alert and all, we will create some other different frequency we will create. Thereby, we will observe some tone. Okay. Now we will see the second exercise. The same experiment. Here I am going to use one push button.
Gajendran, ஒரு question இருக்கு.
Yes, sir.
Suppose if we switch state as a low னு check பண்ணா என்ன ஆகும் அப்படினு சபரீஷ் கேட்டிருக்கார்.
See if you check the very good. See in the code part, if you check if my switch is in low, we will do that one. See, is it visible for everyone? If it is low, what I have to do? If my switch is in low condition, I need to keep my buzzer to low. I need to change my program. HIGH. Is it okay? See, Sabari, if you read the status of the switch, if it is in low condition, make the buzzer to off instead of on. Now we are going to make the buzzer to off. In else part, we are going to make it into high. This program will also work. Check now. See, my switch is in off condition, buzzer is off. Is it okay? See, it is only logical, only two states are available. According to the two state, you need to write the program. It's true or false. In true condition is yours. So what are all the true condition you are going to set? The same thing you need to follow in the program part also. Okay. Is it clear, Sabari? Shall I proceed? Hello?
Okay.
Yes, sir.
Yes, sir. Everyone, please make a note of this change. The logical level is the programmer choice. The programmer has to decide in which condition we have to check. But the required output, the customer will ask the required output. That required part you need to attain. Okay. Now we will come to the tone. See, here I am going to use push button and buzzer. Okay. So why we are using push button and the slide switch again and again means you need to familiar with these two devices. Okay. Now you observe the video. Can anyone tell how many tones you can hear? Whenever I press the push button, it's not giving a fixed sound. It creates some tone. How many tones you can hear? Please type it in chat box. See, I will repeat once again. See, if I 2. Yes, very good. So likewise, you can create n number of tones. Okay. Now I will come to the hardware connection. Please make a note of this. See, whenever we are telling, make a note of it. Sir.
விமல்ங்கிறவருக்கு வந்து ஒரு பழைய இதுலயே ஒரு சந்தேகம் இருக்கு. Probably class end of the classல ஒரு clarify பண்ணிக்கலாம்.
Yes sir, yes sir. Vimal, please hold your doubt. We will come back. Is it okay, Vimal? Yes sir.
கண்டிப்பா பண்ணலாம்.
Yes sir. Sir, everyone please note down pin number alone. Don't take all the circuit diagrams. Circuit diagrams, it is familiar for you. Only the pin number. Here I am going to use pin number 4 and 3. So fourth pin I am going to take it as an input pin, and third pin I am going to take it as an output pin. Same buzzer, same push button. Only the program portion we are going to change a little. Okay. Listen. Void setup as usual. Configure pin number 4 as an input, then configure pin number 3 as an output. Why pin number 3? We will discuss this point later. Now we will make a note of it. Configure pin number 12 as an output. By default, make the pin number 3 to logic low. Now we will check the program. So algorithm portion and program portion is very much familiar for you. Make pin number 4 as an input and 3 as output. By default, I am going to make the output pin as logic low. Then come to the loop section. So what is the algorithm I am going to here? Right here, very simple. Read the status of the switch. It's default. After reading the status of the switch, I need to check the condition of the switch. If my switch is in on state, I am not going to turn on the buzzer simply. I am going to create the tone. How we can create the tone? Take a tone in the buzzer. Else, turn off the buzzer. Else part is very simple, but there also we are going to use some function. Okay. Wherever you are finding new syntax, please make a note of it. Okay. Now we come to void loop session. Again, I am going to read the status of the switch from pin number 4. Then, if my switch is in on condition, just now we read this syntax. So here you are having 3 arguments in this. First one is pin number. The second one, can anyone tell what is this 988? It is frequency. In which frequency we are going to operate our buzzer. The third one is duration in milliseconds. So 1000 means 1 second. So 3 arguments. Please make a note of it. The third one is optional. If I want, I can use. Else I can use only these 2. These 2 is very, very important. Pin number and the frequency in which I am going to operate. Okay. So tone is the inbuilt function. If you pass this variable into this, accordingly the function will get run. Okay. So after some time, I'm going to give delay as usual. Delay. Then I am going to create another tone. What is the change between the first line and the third line in the tone? Can anyone tell? Can anyone tell? Very good. We have changed the frequency alone. So due to this 2 frequency only, you are able to hear 2 different tones from the previous slide. Okay. Now, again, I am going to create the delay for 2 seconds. If else, what I have to do? In else part, if I make pin 3 digital rate of 3, low means my particular third pin will not get turned off because I'm using some other function, tone function. If I want to disable, if I want to off the tone means, again I have to use one more inbuilt function called no tone. Please make a note of it. No tone. In that, only one argument, only the pin number you need to write. No tone, case sensitive, T is capital letter. Please make a note of it. No tone, pin number 3. That's all. The program part is over. Shall we proceed to the simulation? If anyone want take a hint, please make a note of it. Then we will proceed our simulation part.
Gajendran.
Sir,
இன்னித்து இதுலேருந்து ப்ராபப்ளி நம்ம அவங்க ப்ராக்டிஸ் பண்றதுக்கு நம்ம டிஸ்ப்ளே பண்ற ப்ரோக்ராமை வந்து ஒரு வேர்ட் டாக்குமெண்ட்டாவோ ஏதோ பண்ணி அனுப்பலாம். ஸோ தட் தே கேன் இவங்க ஃபுல்லா இது என்னன்னா நோட் பண்ணிக்கணும். அவங்க பண்ணலைன்னா கூட தே கேன் மேக் யூஸ் ஆஃப் திஸ். ஏன்னா சின்டாக்ஸ் ஏதாவது சின்ன தப்பு வந்திருந்தா கூட ஒர்க் பண்ணி பார்க்கறதுக்கு வசதியா இருக்கும்.
And one more thing, only few of them replying for our tasks. Task 1 nearly 40 students respond. For task 2 only 4 or 3 students only completed. If you have any difficult, please call us, because day by day we will increase the task. Then at the end you can't complete all the tasks. Okay, if you are facing any problem at the end of the session, please discuss.
And if you look at it, the way the tasks are structured, or even the classes are structured, முதனா கிளாஸ்ல வெறும் எல்இடி பிளிங்க் பண்றது தான் பார்த்தோம். ரெண்டாவது கிளாஸ்ல ஸ்விட்ச் கத்துன்ட்டு ஸ்விட்சை ஆன் பண்ணா எல்இடி முதனா கிளாஸோட காம்பனண்ட்டையும் சேர்த்து தான் நம்ம இன்க்ளூட் பண்ணி தான் எக்ஸ்பெரிமெண்ட் இது டிசைன் பண்றோம். இன்னித்து கிளாஸ்ல பார்த்தோம்னா ஸ்விட்ச் பஸ்ஸர். ஸோ it is always we are also keep track of what you have run. அதை கொஞ்சம் திருப்பி யூஸ் பண்ணி பார்க்கணும்னு பார்க்குறோம். ப்ளீஸ் ஏதாவது டிஃபிகல்ட்டிஸ் இருந்தால் ப்ளீஸ் கான்டாக்ட் கஜேந்திரன். என்ன பண்ண முடியும்னு பார்க்கலாம். பட் ரைட் நவ் லெட்ஸ் ப்ரொசீட் வித் த கிளாஸ். யா கஜேந்திரன்.
Yes, now we will come into simulation part. Yes. What I have to do? So last class we have seen, if you want to do any modification in this, how we can do. Take the clone of the circuit, how we can take the clone, because hardware things are very much similar to the previous exercise. So I'm going to take the duplicate. I'm going to take the duplicate of my previous project. From the scratch, I'm not going to start. Yes. So here I'm going to rename the program as tone. Okay. Yes. This slide switch alone I'm going to change, because many of them having little doubt with the push button. So we will come to the push button once. We take the push button. See, very simple. Push button has 4 terminals. Give input in 1A means take output from 2A or 2B. This point of view, you take only these points. If you are giving input to 1A, take output from 2A and 2B. If you want, you take it to these 2 terminals, else only these 2 terminals you can use. Today I will going to show, I am going to use only these 2 terminals. I am going to give the input in 1A and I am going to take the output in 2A alone. Okay. Many of them having doubt in this push button. So today,
one easiest thing is, if they don't remember it, always take the diagonal terminals.
Yes, as I told you already, diagonal terminals. If you are giving input here, take the output from the diagonal terminal. Okay. Pull down, keep the thing in logic low. Then I am going to give the input logic high. So this is input terminal, this is output terminal. So same pin number 4. Pin number 4, I'm going to read the status of the my switch from pin number 4. Pin number 4. Let me change the color for our identification. Okay, pin number 4. See, this is input, this is output. Is it okay? Then buzzer, can anyone tell where I need to connect in pin number? Pin number, as per our program, we need to connect the buzzer in pin number 3. That's all. Hardware connection is over. Please check once. We have connected push button in pin number 4. Okay. So the pull down configuration, one end is connected to the resistor as well as the push button. From the common terminal, we are taking the output and it is connected to the Arduino. Okay, the another end of the push button is connected to logic high. Now we will come to the program part. So what are the things we need to change here? Pin number 4 is by default it is input, so no need to change. Pin number 3, instead of 12, I am going to change the program little. Pin number 3. Then again read the status of the switch, that is same. Then I need to check the condition of the switch. If it is in logic high, what I have to do, I need to create a particular tone. So tone, pin number, frequency and duration. Please remember there are 3 arguments here: pin number, frequency and duration. Then I am going to create little delay. For that, different tone. Tone 3, 1000. What we kept in our program? 1047. 1047, 1 second delay. So, duration, that is not a delay, the duration, then delay. Else, what I have to do? Else, can you help me? In else part, what I have to do? No tone. Very good. No tone, only single value we are going to pass, that is simply the pin number. Is it okay for everyone? Input, third pin is output. Then by default logic low, read the status of the switch. If the switch is in on condition, create particular tone and wait for some time. Then create the some other frequency and observe the output for some time. Then delay. If not, make the pin to off. That is called no tone. Now I am going to start simulate my program. See, now there is no output. If I press the button, okay, second time I am going to press. Yes. Is it clear for everyone? That's all. See, I will give you one precaution. Whenever you are doing this tone experiment, you must interface with any one input device without control. If you write the program and if you keep your earphone may get damaged sometime. Okay, for continuous different frequency means your laptop speaker or your earphone may get damaged. Please have an input control. Okay, then only after some duration it will. I hope you are familiar with the serial monitor. It is like a scan-off and print-off action. If you scan something, if you read something, you can print the same thing using this monitor. What we are going to do means, sir already explained everything, so I'm going to make it rush up. We are going to display the text in the serial monitor. Then, by reading the potentiometer, how we can print the values in the serial monitor. Only these 2 tasks. Okay. So first task, please see the animation. In Tinkercad, we are going to type in void setup. We are going to begin the serial monitor function. Then we are going to loop. We are going to type the command as Arduino for everyone. So since I am using serial print alone, continuously it is getting printed. If I include print ln, what will happen? It will get typed in the second line. Second string will get appear in the second line. Shall we try this one? Very simple. Initialization of the serial monitor. In loop, whatever statement we are going to type, we have to type. So serial dot begin 9600. Initialize the serial monitor option with the baud rate of 9600. In void loop, double quote whatever thing we are going to type, that string will get appear in your program. Okay. Print and println. There are two changes we are going to make it in our program. We're going to check the output in the Tinkercad. Same as in Arduino IDE, what's the tool? Same thing we are going to check it here. Before getting into that, let me finish this demo. So, see, where we can use the serial monitor means in the existing program, the switch and buzzer program, in void setup, I have initialized serial.begin 9600. In loop, I'm going to print serial.println SW. What it means? I have initialized the serial monitor. Then I am going to print the status of my switch. Please observe here. I'm going to start simulate it, and I'm going to click the serial monitor will available at the bottom of the window. Please click it once. See, now my switch is in off condition. The logic level is 0. Shall I turn on the switch? See, now the logic level is changed. Is it okay for everyone? So in this way, you can use your serial monitor program to check the change in your program. Okay. So if you want to do some project, first check it here, then start write your program. So off condition 0, on condition 1. Is it okay? Now we will get it into the serial monitor program. Open new project. Open new project. For serial monitor program, it's very simple. We don't want much hardware components. Only the Arduino microcontroller we want. Please take the Arduino Uno. Then, as usual, serial monitor. Then, what is the program? So no hardware we are going to include beyond this. Only our controller. Then I am immediately going to the code part. Text. Continue. In void setup, what I have to do? I have to initialize the serial monitor. So yes, capital letter. Serial dot begin. Serial dot begin. Serial dot begin. The baud rate 9600. And in loop, very simple. You know how to print the
96,000.
Yes, sir. Let me. Yes, serial dot begin 9600. In loop, serial dot println. First, we will check print. Double quote. Whatever the string you want, you can type. Okay. Arduino for everyone. So, start simulate your program. See, if you click the serial monitor window, then only it will get appear. See, serial monitor keeps on typing serial monitor in a single line. If you are not happy with this output, what we have to do? Stop the simulation. Go to the program. Here introduce LN, new line. So the second statement will start printing the new line. Is it okay? So if we want to clear this, click this clear window. The old lines will get clear. Okay. So serial monitor is very simple. The baud rate, whatever the baud rate you are giving over here, this to initialize the serial monitor. Then you have to start print. In our Arduino IDE, you are having more number of settings. In this simulation software tool, you have only minimum settings. Here the beauty is you no need to have an actual hardware unit. Simply if you keep the Arduino unit here, then the serial monitor will work. Okay. Is it okay for everyone? Shall we move to the potentiometer experiment? Yes. So serial monitor, both the things we have checked, print and println. Now, in this exercise, we are going to read the voltage from the potentiometer, and the equivalent, that analog to digital conversion value, we are going to display in the serial monitor. Please observe the video. Please observe the video. My potentiometer now it is in maximum position, therefore it shows 1023. If I keep on move the wiper, see the analog value gets varied, so the equal count also get changes. Once I keep it in minimum position, it is 0. Minimum position, it is 0. If I brings to maximum position, it is 1023. Okay, simple hardware connection. In the existing program itself, we are going to include the potentiometer, and we are going to test this output. What is the code we have to write? Very simple algorithm. Configure A0 pin as an input. By default, all the analog pins are input. A better practice, configure the pin A0 as an input, then initialize the serial monitor. Okay, the equivalent, the code for this one is initialize the pin number A0 as an input. That is as simple as that. Pin mode A0 comma input. How to initialize the serial monitor? How to initialize the serial monitor? Serial dot begin with the baud rate of 9600. Why we are using 9600 as a default means most of the serial communication devices in the market, what we are having, will support 9600. Say example, Bluetooth. Okay. Likewise, you have a number of wireless devices. Those serial communication devices will support 9600. Due to the reason only, we are using 9600 as a baud rate. Then, what is in our main program? I need to read the potentiometer value. Potentiometer output is the analog value or digital value. Can anyone type it in the chat box? Whether we are going to have only 2 state or more than 2 state. Very good. Obviously, it is more than 2 state. So, therefore, we are going to connect our potentiometer in the A0 pin, and we are going to read the analog value. Once you got the value, you can start type the equivalent analog value in the serial monitor. Then I'm going to give a little delay because the hardware component needs some time to change from one value to another. So I'm going to introduce little delay. Before reading the second value, I will introduce little delay. Then I will continue the same loop. Come to the program, read the analog value. Very simple. Please make a note of it. Analog read, here R is capital letter. As like analog write, here analog read. Analog read, digital write. In all the syntax, after the particular word, the second word will begin with the capital letter with no space. So A0. Here what I have did, I have initialized one variable pot value. Pot value is equal to analog read of A0. Then I need to print the variable. What variable I can print it over here? Serial println of pot value. Okay. Then small delay. Then I'm going to finish the program. Is it clear for everyone? Shall I move to the exercise? It's okay? Yes. Now you come to the program. So is it visible, sir? Sir? Okay, sir. See, what I'm going to do, the same hardware setup, I'm going to include only the potentiometer. It's a very simplest experiment. Only the program part alone, you are going to use new things. See, potentiometer is an input device. Potentiometer is an input device. Fetch the potentiometer. As you know already, it has 3 terminals. Terminal 1, wiper arm, then terminal 2. So the wiper arm is the output terminal. Terminal 1, terminal 2 are the input terminals. So what I am going to do? Simply, I am going to connect VCC and ground across the N terminals. Simply, I am going to connect 5 volt at the N terminals. See, now I have connected VCC and ground. Then what I have to do? I need to take the output from the Viper arm. Where I need to connect? See, I can connect it to any one of the pin. A0, A1, A2, A3. There are 6 analog input pins are available. Out of that, we are going to use it in a A0 pin. Okay, A0. So A0, Viper arm, output Viper arm, I have connected in the A0 pin. That's all. The hardware connection is over. Come to the code part. So as for code is concerned, very simple. I need to initialize the or configure the A0 pin as an input. So A0, comma, input. Then immediately I need to initialize the serial monitor with the baud rate of 9600. Then, yes, hello? Hello?
Yes, we can hear.
Yes.
Clear, no disturbance.
Yes. Okay, this setup program is clear for you. Input mode, A0 configured as an input, then serial dot begin 9600. Now come to the loop function. So I'm going to assign the one variable called pot value. Potentiometer value, in short, I'm going to take as a pot value. I need to read the analog value. So therefore, analog read of the particular pin number A0. What will happen? Once I run the code, this analog read function will get run. What it will do, it will read the analog value from this pin. Then it will get stored into the variable called pot value. Then simply we need to print the value, what we have read from the analog pin. So simply I'm going to print. Shall I type like this? Within the double quote, if I type pot value, what output I will receive? Can anyone type it in chat box? If I use this line, within the double quote, if I type pot value, what output I will receive? Can anyone type it in the chat box? Whether I will receive analog output value or simply it will print pot value. Let me check one. See,
they have written almost all of them are type pot value.
Okay, very good, sir. So see, if I start simulate, if I run the program, it will type pot value. This is not our required program. What is our required program? We need to read the status of the value. That means within the double quote, whatever the value you type, a particular string will get print. Without quote, if you print, the value of the particular variable will get print. This is the difference between these two things. Now you observe, I'm going to start simulate it. Very good. Now I am getting 1023. So that is nothing but my Viper arm is in maximum position. Now I am going to move my Viper arm from maximum to minimum gradually. See, the values are getting decreases gradually. Now I reached minimum position. It is 0. Can anyone view this one? See, now I am in minimum position. Now I am going to bring the Viper to the maximum position. See, it is 1023. If I keep in exactly middle, what count value I will receive? Can anyone type it in chat box? If I keep my Viper arm exactly in the middle position of that curve, what will be my count value? So this is exact middle position. Very good. It is around 512. So if I keep exact middle, around 512 I will get.
1023 divided by 2.
2, that's all. 1023 divided by 2. So now successfully we read the analog value. See, if I keep it in minimum position, it is 0. If I keep it in maximum position, it is 1023. In case if you change this polarity, the minimum and maximum value will get varied. Please observe the hardware change, what I am going to do, now I am going to connect VCC here, and ground here. If you change like this, the minimum and maximum position will get varied. See, now I am going to start simulate it. Now, since I have connected the negative terminal here, it become a minimum position. If I turn the wiper into the opposite direction, it will become maximum. Is it okay? So in this way, you can read any analog values. Okay, most of the sensors in the universes, most of the physical quantities are analog in nature. Obviously, you will use any one of the sensor. At that time, you need to use this function. Okay. With this, we are going to stop this demo. Now, I am going to give the task. Please make a note of it.
Within ஒரே நிமிஷம் அந்த பொட்டன்ஷியோமீட்டர் வந்து அந்த வேல்யூக்கு பதிலா வேற ஒரு வேல்யூ இருந்தாலும் இதே ரேஞ்சில தான் வரும்.
Yes. Wait. See, if I want by default it is 250 kiloohm. So I am going to change the potentiometer value as a 10K. Do we get any change in the output? Let me check. I am going to start simulate. See again, the maximum position is same 1023. Minimum position is 0. And what change we will get? The resolution in the output, how much step you can achieve it. Okay, if you increase the resistor value, you will get less precision. If you have a lesser resistor value, you will get higher range of for the angle position. Say example, this is the first step. In the first step, I am getting, what is the value? 1084. See, if I increase the resistor value means for the small change in variation, you will get a larger output. Okay, that is the change. Okay. So even though if I change the resistor value, the minimum and maximum position not going to affect. That's all. Do you have any doubt with this? If you want to see the code once again, see, you are going to read the analog pin. See, initialize the serial monitor. Then we are going to store the value into the one variable name called part value. Then carefully type the value. Okay, if you type it in double quote, you won't get the exact output what you want. Okay. Anything else you want? See, here you have a different multi-level voltages. If you change it to the different value also, you will get the different output. The maximum value is, if I instead of this 5 volt, if I connect it across 3.3, the maximum value will get varied. Instead of 1023, you will get some other value. See, the equivalent to the 3.3. Okay, that we will sort out later. Okay. Else we'll try once again. Y minus 0. See, the maximum value now it is reduced to 675. Why it is 675? Because instead of 5 volt, I am giving 3.3 volt is as a maximum value. Therefore, my maximum range it narrow down to 675. Within 675, you will get the different values based on the wiper position. Okay. So, shall we stop here, sir? Sir?
Then Ram Prasad is one share pannunaru. I think we'll stop here. But Ram Prasad Sultana, then probably.
Gajendran sir, pin number 0 and 1 வந்து serial port நம்ம யூஸ் பண்றப்ப வேற எதுக்கும் யூஸ் பண்ண முடியாது அப்படின்றது.
Okay, see, and one more thing, see, if you observe the pin number 0 and 1, this is transmitter and receiver end. So whenever you are using any serial communication devices, so most of the time don't use these two pins because The same serial port pin, we are using it for USB communication also. Okay, to try to avoid these two pins and use remaining pins. Okay, this is RX and TX pins. If you are having any Bluetooth, any serial communication device, simply you can connect those devices.
Only when we use serial communication. Other times we can make use of it.
Other time you can make use of it. Yes. Now we will take. So shall we take the task, sir?
Yes, sir. Yes, Ram.
Yes. Yes. Please make a note of it. Today we have completed buzzer and serial monitor. Based on these two things, we are going to give only 3 tasks. Please make a note of it. If the switch is in on condition, make the buzzer to on, else turn on the LED. In our actual experiment, else part, we will make the buzzer to off only. But here we are going to include one more thing. If my switch is in on condition, my buzzer has to turn on. In else, I need to turn on the LED. That means turn on the LED, make the buzzer to off. Okay. So if my switch is in on condition, buzzer should be in on, LED should be in off. Else, turn on the LED, turn off the buzzer. Can you do this one? Please take down the statement. First task is very simple. What are the hardware things you want? Please think it over and do it. I'm moving to the second task. Shall I move to the second task? Do you have any doubt?
You can post it there.
Yes,
you can explain it or post it.
Second one, see, using analog read as well as the potentiometer, that is serial monitor. Together you need to use. Please read the question once. Read the analog value from the potentiometer and generate visual and audio alert. If the analog value is greater than 2.5 volt, please make a note of it. Read the analog value from the potentiometer and generate visual and audio alert if the analog value is greater than 2.5 volt. This is your second task. The final task, very simple. Interface 4 LEDs and a potentiometer with Arduino. If my potentiometer output is 25%, LED 1 should on. If it is 50%, both LED 1 and 2 on. If it is 75%, LED 1, LED 2 and LED 3 all puts it on. If my output is 100%, all 4 LEDs you need to make it into. I hope you can